Hey everyone, welcome back to another video. Today I will show you some filament you've probably never heard of. This filament is not only electrically conductive, but it can also stretch. The filament I'm gonna show you today is just like this orange Ninja Flex material E-TPU. However, this magic material contains carbon nanoparticles and is therefore electrically conductive. But before we can make an attempt to print any of this material, I need to convert my printer into a somewhat more direct drive system, since this incredibly long Bowden setup is not gonna do any good. So let's start the conversion. This custom printhead uses a tapered screw and some sandpaper to hold the Bowden tube into place. So now let's remove the Bowden tube. And as you can see, I screwed up and broke something off. So that's why I'm using the other side of the printhead now to continue my experiments. And now it's time to build a very janky setup to hold the extruder and the motor. And if you thought it couldn't get more professional than this, well, it's time to buckle up. And for all the people that leave their zip ties cut like this, please get some help. And now it's time to install the extruder onto the moving bungee. After the extruder is mounted, a very short section of Bowden tube can be inserted into the extruder. And this small section of PTFE tube will then mount into the printhead. After everything is tightened, this is now the current setup of the printer, which looks absolutely ridiculous. But if it looks stupid and it works, it ain't stupid. Now let's jump over to the Prusa slicer and see what kind of test part I have created for this filament. And the criteria was that this part needed two large surface areas for a conductor to be mounted to, such as a copper wire or copper tape. And also the print direction is pretty important for the conduction. So if you print in the same direction as shown here as the electrode placement, then you have a better conduction than if you would print perpendicular to that. Let's fire up the printer now and see if anything useful comes out. Well, indeed we have something that looks like the part in Prusa slicer. The only thing we need to do now is to mount two conductors to it. Luckily, I have a very fancy multimeter with some plotting software, so we can do some different things to our sample. For example, stretch it, and by stretching it we change the cross-sectional area in the middle, and therefore the resistance goes up. And for example, we can also squeeze the contacts with our hands, so the wires make better contact with the E-TPU, and therefore the resistance goes down. So, for example, this material could be used in something wearable that makes electrical contact with your skin. Let's think about ECG signals and stuff like that, muscle detection, sweat detection. You could also put this in a drone arm, for example, to detect any flags. Or you can make some kind of a fancy switch or some other thing with Arduinos involved. So the possibilities are endless with this material. And as a final example, I have connected an LED to our magic plastic, and by stretching it we can see the brightness goes down, and by relaxing it the brightness goes up. So if you're interested in this material, I will leave a link in the description so you can find it. If you have any questions regarding this material or any suggestions for me to do more experiments with it, or any questions in general, feel free to leave them in the comments. If you enjoyed this video, leave a like. And I hope you learned something, and remember, just try to DIY.